Welcome to the tutorial on Introduction of MATLAB. This tutorial has been prepared for the beginners to help them understand basic to advanced functionality of MATLAB. MATLAB is a programming language for technical computing. It is developed by MathWorks USA. The name MATLAB stands for Matrix Laboratory because it started out as a matrix programming language. The different versions has been launched from time to time to increase the functionality and features of the MATLAB. It is widely used in universities for academic and research purposes. In industries, the software can be used for research development and design. The language finds wide applications in different fields, especially engineering, including all the fields of engineering. It can be suitably applied. Also, it can be applied to the medical sciences, financial sectors, banking sectors, and industrial sectors, etc. The MATLAB software can be divided into two parts, MATLAB and Simulink. In the MATLAB, the technical computing part can be taken up. In the Simulink, simulation and model-based design is carried out. Both MATLAB and Simulink have toolboxes that are a collection of specialized programs designed to solve this specific type of problems. For example, the different toolboxes like signal processing, symbolic calculation, control systems, physical modeling, event-based modeling, and optimization can be carried out. The MATLAB technical computing part allows matrix manipulations, plotting of functions and data, implementation of algorithms, creation of user interface, and there is also possibility of interfacing with other programs written in other languages, including C, C++, and Java. Simulink, on the other hand, is an environment for simulation and model-based design for dynamic and embedded systems. It provides an interactive graphical environment and a customizable set of block libraries to design, simulate, and implement different time-varying systems, including communications, controls, signal processing, video processing, and image processing, etc. MATLAB can be downloaded and installed from mathworks.com, which provides a licensed product, a trial version, and a student version as well. MATLAB integrated development environment can be launched from the icon which is created on the desktop when the software is installed. This is the default layout of MATLAB desktop window. The window consists of four small windows, as we can see here. The name of the different sub windows is the command window, the current folder window, the workspace window, and the command history window. This is a default view that shows four of the various windows of the MATLAB. The current folder on the left side allows you to access the project folders and files. That is, all the programming files that have been created will be saved in this folder, and the path of the file can be located through looking at the current folder. The command window is the main area where commands can be entered at the command line, and it is indicated by a command prompt. The workspace shows all the variables that are created and imported from the files. The command history window shows all the commands that are entered at the command line and command window. To explore the different features, functions, and toolboxes of the MATLAB, click on the Help menu. On the Help menu, you have a drop-down list, so you can click on the first option, Documentation, which will give you the details of all the toolboxes and features available in the software. When you click on the documentation, you'll see the different features of MATLAB and Simulink, including all the toolboxes will appear. The marked with the sim are indicating all the features available with the Simulink part of the MATLAB, and the rest are associated with the MATLAB part. So different toolboxes are there. When based on the application, you can use any one of that. What is the problem you are taking up, and based on that, you can pick up the suitable toolbox. You can click on any one of the toolbox which you are using, which will give you the further details of what are the different functions and features available with the toolbox. And also it will be giving you the demo examples that will help you in writing the codes or making the models. Now let us see the different elementary math functions in MATLAB. ABS, SIGN, trigonometric functions, that is sine and cos, To calculate the inverse trigonometric function, we can use a sine, a cos. To find exponential, exp, logarithms, we have the different functions available. For performing the rounding of or the flooring, we have the different functions of ceiling, flooring, and rounding as ceil, floor, and round. To calculate the real and imaginary parts of a complex number, we have real and imag keywords available. Sort is element, which sort will be sorting the elements in ascending order. So these are the different mathematical functions that are available in the MATLAB. And it can be seen here that all the math functions will be written in the small letters. So we can say that MATLAB is case sensitive. Here we can see that MATLAB has also relational operators and logical operators available. So there are 6 relational operators in the MATLAB, and MATLAB also supports 3 logical operators, not, and, or. The examples shows the application of these relational and logical operators as applied on the variables a and b, and we can also see what is the syntax that has to be used while applying the different type of relational or the logical operators. Let us now create a row vector and column vector in the MATLAB. To create a row and column vector, we need to write the statements in its specified syntax on the command window. That is, to type a command, the cursor must be first placed next to the prompt. And once the command is typed, we can press the enter key, the command will be executed. So here we want to create a row vector first, and let us define that row vector by a variable x. So we are creating a variable x which is in the form of row vector we want to create, and it is having the values 0, 1, 2, 3 and 4, 5. So in order to write this, we need to first write x equal to, in the square brackets we have to write all the entries of this vector. So after writing all this, at the end of the square bracket you can click enter key. So when the enter key is pressed, the result is displayed like this. So we have created a row vector. There are different ways of creating a row vector. We can put a comma between the entries or the values of the vector. So the vector x has been repeated again when we are typing now. The second statement is at the prompt x equal to 0, 1, 2, 3, 4, 5, and all the entries need to be entered in the square bracket. We are again pressing the enter key to execute this statement, so giving us the same result. So we got the row vector again, the same row vector. Now, if we put a semicolon at the end of the statement, then what happens? So when we are writing x equal to the same vector and entering the semicolon at the end, it will simply suppress the display of the executable statement. The statement gets executed, but the result display is suppressed here. However, if we wish to see what is there inside the variable that we have just executed, so you can see on the right side on the top you have a window called workspace. So all the variables which will be executing will be stored in this window, which is called the workspace window. And you can see here the x has been displayed here with its values 0, 1, 2, 3, 4, 5, and just before x you can see one small icon is displayed. This icon is indicated that this is the variable which is stored in the workspace. Also, if you want to create a column vector, you can have a look on the command window. Now we want to create a column vector of variable name. We are giving it y. So in order to create a column vector, again the entries of the column vector will be entered in square bracket, but now the values or the entries need to be separated by a semicolon. So we are putting a semicolon after each value, and we are executing it by pressing the enter key. So you get a result displayed like this. So this is the column vector that we wanted to create. Now, the other way of creating the column vector by suppressing the result is we need to put a semicolon at the end so that we can suppress the display only of this executable statement. Also, if in order to take the transpose of this y vector, suppose we want to take a transpose and we want to store the result in another variable named z. So we can type here z equal to y dash. So when you execute this, this is actually doing the transpose of the vector y, and the result will be stored in z. Again, have a look on the workspace window on the right side, you can see that in the command window we have created three variables x, y, and z. So all the three variables along with their values get stored in the workspace window. Also, you can see on the lower right hand side there is a window, sub window called the command history window. This is containing all the statements that we have executed on the command window. So this is the history of all the statements that we have written at the command window. So from this also you can see these are the different commands, and you can pick up from this window also any of the command that you want to re-execute this. You have to simply select that and right click on that and evaluate the selection to rerun the same statement. Let us now see the other way of creating the vectors. Here we are creating a vector, row vector r1, and we want to create this row vector r1 with the initial and final values specified, and we want to put a suitable increment between the input and initial and the final values. So let us create a vector, row vector r1 with the initial value 0 and the final value 1, and we want the increment to be 0.5. So the syntax to write is we have to first write the initial value, put a colon, write the step size or the increment which we are writing here 0.2, and again colon and the final value. So this gives us a, after executing the statement we'll be getting this answer 0, 0.2, 0.4, 0.6, 0.8 and 1, right? And we have assigned this a variable name x1. So you can see on the workspace you have now an additional variable x1 also stored in your workspace. Let us create one more vector x2, and we are utilizing an inbuilt function length space for that. So the length space will be creating a linearly spaced vector of the values initial value 0 and the final value 1, and the 6 is written here. The 6 indicates that how many values you want to create. Suppose we want to create any vector between 0 and 1, and we don't know what is the exact size of increment should I take, but I know the number of values that are required in between that, then I can use the inbuilt function length space for that. So we are storing the answer in x2. So x2 gives me the initial value 0, the final value 1, and in between it has automatically taken the step sizes based on how many values we require. Also, if I want to see what actually length space is doing, then we can type help length space and we can explore what length space is actually doing. The detailed documentation is provided here, and what is the syntax for that? This is also written length space x1 comma x2 comma n. So this will be creating the vector of linearly spaced values, right? So that's what we have done this. Now suppose we want to see how many values are or how long is the vector, then we can use the keyword or the inbuilt function length to identify that. Suppose we want to calculate the number of values which are stored in the vector x1. So we need to write length of x1. Length will be operating on x1. So we can read it like this, length of x1. Also, you can see that all the keywords or the inbuilt functions that we are calling like length space or length, these will all be written in the lowercase. Also, you can see on the command history on the right lower side, you can see that whatever statements we are typing at the command window at the prompt, and all the statements will also be displayed here. And if you want to use any one of this or we want to repeat any one of this, so instead of typing you can just right click on that and evaluate that selection. In order to save the variables which are stored in the workspace, we can click on the drop down of workspace located right to the word workspace, and we can see here the different options are there. We can click on the save, and that will be saving this entire workspace window which is consisting of the different variables, and this will be stored in the current folder once it is sub window is saved. Similarly, you can see on the right side command history is written. If you want to execute a particular statement again, then you can select that one, and that gives you an option of evaluating that selection again.